good morning. Today is the 22nd March and it is Sunday, and we are going to continue with the radical number. This is the second video on radical number. Today we are going to see the operation on radical number. We are going to learn operation on radical number, means how to do addition, subtraction, multiplication and division of radical number. Is it okay? So get ready. The first question we will take here is question number 1A. It is on page number 60. Exercise question number 1A. The question is root over 48 plus root over 12. So these are the two radical numbers we have to add. Is it clear? So as I told you in the previous video, that the operation of any radical question will be done in the same manner, will be done on the same pattern, and we will use the concept of factorization. Right? We will use the concept of factorization. Either that factorization can be a general method factorization or it can be prime factor method. Whichever way you are comfortable, you can do, and then we can simplify. So let us begin this question. Right? Okay, I am going to do it by general factor method. This 48 we are going to simplify first of all. So we will write all the possible pair of factors. 1 into 48, 2 into 24, 3 into 16, 4 into 8, 4 into 12, then 6 into 8. So this many pair of factor we have. Now from here we will choose one pair of factor which will have the biggest perfect square. This pair of factor has this as the perfect square. This pair of factor has this as the perfect square, and this also has a perfect square 1. Clear? Now out of this all the three, 16 is the biggest factor, biggest perfect square. So we will choose this pair of factor to replace this, and therefore we can write this as root over 16 into 3. Is it very clear? So the first radical number is simplified. Now likewise we can write the factor of the other radicand also. In between there is a plus sign, so write plus sign. So now this number b is a very small number. We can do it verbally. This we can factorize, keeping in mind that our one factor should be a perfect square number. And then I am factorizing this as 4 into 3. 4 into 3, because you know 4 is a square. Right? And the purpose of factorization is so that we can reduce these radical numbers. Isn't it? So we will now, those numbers which are perfect square will be able to come out of the radical sign in the form of a square root. So this will become 4 root 3. And this will become 2 root 3. Is it okay? Now if you look at the two radical number, these two radical numbers are like terms. Why they are like terms? Because their radical sign and the radicand, these radical parts are same. Therefore they are like term, and therefore their coefficient can be added. The coefficient of this radical number is 4. The coefficient of this radical number is 2. Just because they are like terms, therefore their coefficient can be added, and finally your answer is 4 plus 2, 6, 6 root 3. This is done. Hope this question is not very difficult. Okay, next is B. This is root of x cube and then minus square root of 49x. Is it okay? Now we are going to simplify this. We are going to reduce this radical number, and we will also reduce this radical number. After that, if we find like term, we will simplify. Now this is in the form of exponential number. So the exponential numbers can also be factorized by splitting the power. The exponential number can also be factorized by splitting the power, right? When you split the power, your one power, because the radical sign is square root, therefore your one power should be in the term is a multiple of 2. your 1 power has to be a even number. Clear? You split this in such a way so that your 1 power comes in the even number and other power comes in the odd number. Is it okay? So we will do this like this. We will do this question. X cube, we will split like this. X cube will be written as x square into x. Isn't it? Minus as it is. And for 49, you know that 49 is a square number. So straight away we can take it out. So 7 is out as 49 is out as 7, and then remaining we have is x. Is it okay? Now, when you have splitted this power in the form of even power and odd power, right? The even power always gives you a perfect square. This is always a perfect square. Therefore, its power will be reduced by half and will come out of the radical sign. The even power will reduce by half and will come out of the radical sign. So this will come out as x, right? And this will remain inside as it is, x minus 7 root x. Now you can see here, this is simplified. This is simplified. After this, now they are like term. They are like term. Same like this. These are also like term. But the problem here is, because their coefficients are such. Coefficients are such. So we can't do much. But what we can do here is, the last step is, we can just take out the radical sign as a common factor, and the remaining we can write inside the bracket. So x minus 7 and then root of x. What we did is, the radicand part was found common factor, and therefore we have taken it out, and then the remaining we wrote in the bracket. This is how we factorize this. Is this okay now? Okay. Let us see one more question. Number C. Number C. Number C is, it's very simple question. 7 root k. 7 root k plus 9 root 9k under root. 9k under root. Is this okay? Now look at this question. This question has two parts. It is a binomial. This part and then this part. Right? This part there is nothing to do because it is already in the simplest form. Right? This is a mixed radical number, where this is a whole number part and this is the radical part, and the radical part is in the simplest form. This cannot be factorized, simplified anymore. So we will leave it as it is only. Only this part has to be simplified, and out of this part 9 is a perfect square number, so 9 square root will come out. So the first term is as it is, 7 root k, and then second term will become 9 will come out as 3, and therefore root k. Now these two are also like term because their radical sign and the radicand are same, especially the radical signs are, and then radicand, both are same. Therefore these two are also like term, so their coefficient can be similarly added. So 7 plus 3 is equal to 10. This is 10 root k. Hope this is very clear. Okay. Now there is one more question in number 1, and so I thought I will do that question also, so that you get very clear picture, because this is the beginning of the operation on radical number. More the sums you see, your doubt will be more and more clear. So let us see the last one more question of number 1. It is D. D. D is root over 44. Root over 44 minus root over 121. 121. And then last term is root 55. Root 55. Now let us, there are 3 radical numbers. Let us simplify all the 3 radical numbers and then see how much we can simplify. Now we start in the next step here itself. This 44, we will try to factorize if possible. Sometimes it may not be possible. But this 44 can be factorized as 4 into 11. This is the only one pair of factor where you will get a perfect square number 4. Minus this 121 is already a perfect square. You know, like it is a square of 11, right? And then last one is 55. This number, if you factorize also, you are not in a position to do anything, right? This can be factorized simply as this factor. This number has a factor 1 into 55 and 5 into 11. 5 into 11. Now in both the pair of factor, we don't have any perfect square, and therefore there is no point of simplifying it. We can leave it as it is. If our number does not give you a perfect square in the factor, then we don't need to factorize it. Then we don't need to simplify. Okay. Now the last step is here. This will become, the square number will come out. So this is 2 root 11, right? And this will come out as 11, right? The square and square root is cancelled. Clear? Because the square root is power half and this is power 2. So 2 into half is 1. Therefore, this is this. And now plus root over 55. This remains as it is. Now we have simplified all the three terms, whatever was possible. But after simplifying, what we have noticed is there is no like term. And since there is no like term, so this is itself is an answer. This is question number 1. Okay, thank you. Now the next question is question number 2. Question number 1 was based on addition and subtraction. Question number 1 was based on addition and subtraction, but now question number 2 is based on multiplication. Question number 2 is based on multiplication. This one by one, I'm trying to show you all the different type of operation, right? So first operation we have learned was the addition subtraction. Now we are going to learn about multiplication. So that way we are learning the rules made for addition subtraction, rules for multiplication division. Clear? Okay. So we are going to continue. Root 12 into root 3. First of all, I will tell you every radical number will be simplified in the same manner, whether it is addition or subtraction or multiplication or division. Every radical number will be simplified by using the factorization method. So we will continue. Now this 12 can be factorized as root 4 into root 3. Now you might have started understanding. The minute you see the question, you might be getting the answer in your mind. And this is next number is root 3. Is it okay? Okay, now from this part you can see that the 4 is a perfect square number, so it's a square root number, its square root will come out, and the square root of 4 is 2. And then here the remaining is root 3. Is it okay? Into root 3. If you remember the addition or subtraction case, then we were telling that these two are like term because there was a plus or minus sign. There was a, please be very, very mindful of the operation because this is the place where we are making mistake. In the addition subtraction, when it was addition subtraction, then we were calling this as like term. And then we were adding their coefficient. Clear? But that will not happen. We will not use the term like term. We will not use the word like term for the multiplication case. Right? In fact, in the multiplication, we will multiply the radical part and we will multiply the whole number part. Directly we will multiply the whole number part and the radical part. Now, the whole number part, the coefficient of this one is 2 and the coefficient of this one is 1. When there is no number, it is 1. So we multiply the whole number part. 2 into 1 is equal to 2. Is it okay? Now we are going to multiply the radical part. Root 3 into root 3. Right? You need to know that root power means, square root means power half. Square root means power half. So root 3 into root 3 is actually what? 3 to the power half into 3 to the power half. Is it okay? Now these two are exponential number where the bases are same, so the power can be added. So when you take a common base and add the power, half plus half becomes 1. And therefore the result of this root 3 into root 3 is always equal to 3. Similarly, if we can have root 2 into root 2, the answer will be always 2. Root 4 into root 4, answer will be 4. Root 5 into root 5, answer will be 5. So this root 3 into root 3, answer is 3. And therefore your answer is 6. Hope this is very clear. Okay. Number B is root over 4x to the power 5 into 5x to the power 3. 5x to the power 3 root over. Okay. Now, in the multiplication or division, right here also, in any case, if there is multiplication or division, we can have a common radical sign, right? Or you can simplify separately as you have done here in this question. You have simplified this part, then this was not possible, so you left it as it is only, and then you have taken out the square root sign, perfect square number, and then finally you have simplified. So let us do in the same manner here also. We can have, this is a perfect square number, so this will come out as 2, okay, as 2, right. Now this is exponential number, this exponential number we can split, or the better method is, in place of doing it separately, we can use a common radical sign for this all. Common radical sign for all this. So we will write here 4 into 5. Is it okay? Now this two radical number also we are going to multiply. We are going to multiply the two radical number, and just now only I showed you that x to the power 5 into x to the power 3, right? For this is the exponential number. This is the product of the two exponential number where the bases are same. And in class 9 you have learned the exponential rules, which in the product form it says that if the bases are same, the power can be added. Power can be added. So this will become x to the power 8. Am I very clear? So with this concept, we will be able to write the product of this x to the power 5 into x to the power 3 as x to the power 8. Am I very clear? After this, what we can do here is, out of these two numbers, this is a perfect square number, so just take it out as a square root sign, okay? And then this will remain inside the radical sign, so we will write this later on. First of all, we will deal with this one. And how we will simplify this is, because the power of this one is an even number, so that's a very good information. That's a very good information that the power of this one is an even number. When the power is an even number inside the radical sign, then it is very easy for us. We can just reduce the power by half and take it out. Because when the power is even number, it is indicate that it is a perfect square number. So it will come out as x to the power 4. So what was left only in the radical sign is root 5. So we will leave this root 5 as it is. Is this okay or not? Now finally we will do the rearrangement, all the numbers together. So 2 root 5 and x to the power 4. This is your final answer. Is it okay? In question number 2, we have one more part, C. Part C is root of 6 into root of 7 into root of 2. Is it okay? Now, what I told you, in the multiplication or division, if the radical signs are same, please be very mindful, only when the radical signs are same, then no need of using this radical sign for 3 times. No, we can have a common radical sign and all this number will come in the form of product under the radical sign. So we will write this as 6 into 7 into 2. Is it okay? Now, if possible, you can factorize it also. Now, out of this number only can be factorized, so we can write this as 2 into 3. This is as it is because it's a prime number. This cannot be factorized as it is, and this also is a prime number. This cannot be factorized as it is. Okay. Now, finally, what do we get? This 2 and this 2, right? Will be 2 into 2 is 4, and 4 is a perfect square number. So in place of these two, we will that 4 product will come out as a roots as a whole number. Will come out of the radical sign as 2. Okay, and remaining this 3 and this 7. This 3 is a prime number. This 7 also is a prime number, so they cannot come out of the radical sign. So simply they will be multiplied and will remain in the radical sign. So 3 7 is 21. This is your final answer. Is it clear? So this is your question number 2. Thank you. Alright, now we are moving on to question number 3. Question number 3 is about division. Is about division on division of radical number. Actually, this question number 3 also should have been mixed with question number 2 only, because there is no separate rule for division. The rule for division and multiplication is same, right? So let us start and then see. Question number 3a. In the multiplication also I said, when we have many radical signs of the same type, we need not to have many radical signs. In place of having so many radical signs, we can use one common radical sign. And the same thing we can apply in the division also, right? We will apply the same concept in the division. Now you can see here we have this root 48 divided by root 12, right? This both the radical signs are same. Just because the radical signs are same, so we are able to do that. In place of having two different radical signs, we can have one common radical sign for both. Am I clear? Okay. And we can also write this as, you know that division also can be written in the form of fraction number. So I will write this division in the form of fractional number. This is root over 48. First of all, I am just rewriting the question as it is. In the fractional form, this is root over 12. This is well understood. Now, here in place of having one radical sign for the numerator and one radical sign for the denominator, we will just keep one radical sign, common radical sign for both numerator as well as denominator. See how the work becomes more easy. This is 48 divided by 12. And now this radicand we will simply see as a fractional number, as a normal fractional number. And the way we used to reduce the normal fractional number, we will reduce this fractional number also. So when you simplify this 12 1s are 12 and this 12 4s are 48. So finally your this radical number reduced to only 4. Now see, this heavy question has become so light question, and everybody understands that what is the square root of 4. So that will be your answer. Is it well understood? Okay. Let us move on to the next question. Number B. This number B is root over 90 divided by root over 20. This is your another question. Now once again, this division question, I will try to write this in the fractional form. So it will be root over 90 divided by root over 20. Right. And then we can give a common radical sign. This will be 90 over 20, right? And now you can simplify. This is 0, cancel this to 0. Is it okay? Finally, you are left with what? Root over 9 over 2. Isn't it? Now, you can see the numerator and the denominator. Now, this cannot be simplified anymore, right? We cannot simplify and then leave the answer in decimal. That we cannot do. Okay, it's a radical question because finding the square root of a decimal number will be very difficult for you. So that is why we will not take the risk of changing this into a decimal. This is our reminder to all. So what we can do is now we will try to see if any of these two, numerator or denominator, if any one of these two is a perfect square number, then that number will come out. This will be inside. So this 9 is a square number, so it will come out, and then the down it will be denominator as it is only. Because root 2 is not a perfect square number. So numerator is rationalized, and it came out, and then the denominator remains as it is. Is this okay? But this is not the end of the question. Though you have simplified the numerator and you have simplified the denominator also, and then you came to this step, but this is not the end of the question. Is because when you have this radical number in the denominator, it is supposed to be an irrational number then. Now this is supposed to be this is said to be an irrational number, and we cannot leave the answer in the irrational form. Irrational means unreasonable. So when we solve a question, we should be able to give a reasonable answer. Is it okay? Therefore, this has to be rationalized. And now, so we are going to rationalize it. For rationalization, the process is very simple. You take the number, the same number, because you want to rationalize this root 2. So you can multiply this by itself. Clear? Now, since you have multiplied the denominator by this root 2, this means you have to also multiply the numerator by the same number. You cannot just multiply one part of it. If you just multiply one part of it, then the numerical value of the quotient gets changed, and you have no authority to change the numerical value of a quotient. Therefore, maintaining the identity of the quotient, you can do any operation. So we have multiplied this by denominator by root 2, and you are multiplying the numerator also by root 2. Ultimately, what happens is we are not changing the quotient. The quotient remains as it is, because once again, if I simplify this, the quotient comes back into its own form. Right? And therefore, now we can write the final answer. So numerator will become 3 root 2 and then divided by 2. This will be your final answer. Is it very clear? Now we are moving on to question number 3C. Question number 3C is another division question. Right. Once again, we will change this division into fractional form. So we will write this as root over 27 x to the power 3 divided by root over 3x to the power 3. Is this very clear? Now we can, this is power 7. This is power 7, not power 3. Okay? Now this is power 7. This is power 7. This is power 7. This is as it is, power 3. And this is power 7. So this 27x to the power 7 divided by root over 3x to the power 3. So the same thing I wrote in the fractional form. After this, I told you this is because division case, we don't need to have a separate radical sign for numerator and denominator. We can give a common radical sign for both. 27x to the power 7 divided by 3x to the power 3. Right, and after this we will simplify and reduce the radical number. So number will be simplified first of all. 3 1 ja 3 and 3 9 ja 27. 3 9 ja 27. This is x to the power 3, this is x to the power 7, so this will be completely vanished and this power will be reduced by 3, so 7 will become 3. Now denominator became 1 and numerator is now root over 9x to the power. When the power of this numerator reduces by 3, then 7 will become now 4. So 9x to the power 4. Now it's very easy for you. You know that 9 is a perfect square number. So this will come out x to the power 4. 4 is an even number. So this variable also will come out, reducing the power of this by half. And finally your answer is 3x square. This is your answer for part C. Is it alright? There is one more question left in D3. So let me show you that question also. Root over 28 into root over 10 divided by root over 21. Root over 21 is equal to what? Now look here. Here we have mixture of multiplication and division. Multiplication and division. And why this multiplication and division is together is because we have a common rule for multiplication and division. That is why we can have this question. Now here in the numerator there are 2 radical signs, denominator also there is 1 radical sign. So all together in this question there are 3 radical signs and all the 3 radical signs are same. So why to have so many radical signs? Now let us have one common radical sign for all the 3 terms and we can have this as 28 into 10 divided by 21. And now we can simplify. Simplify and then see what we can get the final answer. So 7 3s are 21. 7 4s are 28. Okay. Please remember, because I don't have much space, so I am writing it here. Actually it is not outside, it is inside. Is it okay? Anyway, I will show you inside only, otherwise you will make mistake. 4s are 7 4s are 28. Is it okay? Now nothing more can be simplified. Now you have got 4 into 10 over 3. Now out of these 3 numbers, whichever part is a perfect square number, that will come out and rest will remain inside the root sign, and that will be your final answer. So out of these 3 numbers, only 4 is a square number, so only that part will come out and the rest will be inside the radical sign. So this is 10 over 3 and this is your final answer. Hope this is very clear. Thank you. Okay. Now we are moving on to question number 4. Question number 4 is again a very simple question. It's based on simplification, no? Where we have to use multiplication, addition, subtraction. So what we can do is in class 9 and in class 8 also you have learnt about the algebraic multiplication. Algebraic multiplication. Multiplication a binomial by binomial. Multiplying a binomial by binomial. So here this is a binomial and this also is a binomial. So these 2 binomials are going to be multiplied. So when you multiply the binomial, the rule is very simple. You already know. I'm just reminding you. Okay. You take the second binomial and the second binomial will be multiplied by each term in the first binomial. Right? That means this binomial first of all will multiply it by this, by the first term, and after multiplying by the first term, then again we will re-multiply this by the second term. And after multiplying, we will see what next step is. Okay, let us start. So this into this is, when you multiply the two number, the whole number will be multiplied by whole number and the radical part will be multiplied by the radical part. So please be mindful of that. So here we have only whole number, so whole number is multiplied by whole number, 4 3s are 12, and radical number is as it is, 5. Now I'm going to multiply this by this. So the whole number is 3 and 2, so 3 2s are 6, plus both are positive, so plus 3 2s are 6, and root 5 into root 11 is root 55. So first we have finished multiplying this by the first term. Now we are going to multiply the same binomial, second binomial by second term. So we are multiplying this one. Now in this we have only radical part, and here we have only whole number part. So the product of these two will remain as it is. One is negative, one is positive. Please be very mindful of the sign. It will be minus 4 root 11. Clear? Now we are going to multiply this to this. So here we have 2 and here the whole number is 1. So 2 1s are 2, minus plus minus and 2. And now root 11 into root 11. I told you just now only a few minutes before. 2 into root 2 is 2. Root 3 into root 3 is 3. Root 4 into root 4 is 4. Therefore, root 11 into root 11 is only 11. So this is 11. Clear? So now finally, this cannot be reduced because it is a prime number. It will remain as it is only. This number also cannot be factored because even if you factorize also, it is not giving you any perfect square number. So this will also remain as it is only. We don't factorize a radicand if it does not give you a perfect square number. This also is the same condition. 11 is a prime number. This cannot be factorized only. So this is this, and then this answer is minus 22. This is your final answer. Is it okay? Let us see the last question for the day. Number B of question number 4. This is root 13 minus root 5x. Root 5x. Is it okay? And then into root 13 plus root 5x. Root 5x. Alright, now this question is similar to this question only. So here also we can do by multiplying. Now we have learned the process of multiplication. We can apply the same method here and we can get the answer. Is it very clear? Now here I will like to tell you one thing is, yes, we can do it by normal multiplication and you can get the answer. There is no harm and you will get full marks also. Okay, you will get full marks. But those students who are smart, no, when they will see this question, they will understand that this is not necessary for this question to use the multiplication method. We can go for the formula. If we remember this formula, we will do this within no time. And the formula is the difference of a square. A square minus b square. Right. The factor of this a square minus b square is a minus b into a plus b. A plus b. This is the factor of your difference of a square. Now if you match your question with this formula, then you will realize that this question is in the form of factor. Isn't it? Where you have the first term of these two are same, second term of these two are same, and in one bracket you have minus sign, other bracket you have plus sign. The same situation you have here in this question. The first two terms are same, these second two terms also are same. In one bracket we have minus sign, other bracket we have plus sign. That means this question also belongs to difference of a square and it is given in the form of factor. So since you have this question in the form of factor, you can straight write this in the form of difference of a square and get the result. So we can write it as, we can have the square of the first term. The first term is root 13. So you can have this as a square of root 13 minus, in the formula you have minus, so minus, and then the square of the second term. Square of the second term. And second term is root 5x. And then you just square it. Clear? You know that a square and square root will cancel each other. So this will give you 13. And here also square root and square root will cancel each other. This will give you 5x and this becomes your answer. Done? So that's all for today's lesson. I am not giving you any assignment as such, because you are going to do all the questions from question number 1 to 4. I have solved each and every question from question number 1 to 4. So after understanding this lesson, your assignment will be to practice these questions at your own. Right? Thank you so much. Have a nice day. Take care.